Yeah, am I audible? Please let me know in the chat box. Yes, so let's start this particular session. Yeah. So in our previous sessions, we were discussing about write driver and read driver, those particular things we were discussing. And let's give a small pause to our project and we are going to discuss about something known as functional coverage. Since we need to have that particular understanding of functional coverage in our project, so that's the reason we are going to switch to functional coverage and we are going to learn about functional coverage and all. And those particular concepts we are going to implement it in our project decoder based RAM. Okay. Now, before going to functional coverage and all, let's assume that you are a verification engineer. Okay. So if you are a verification engineer, then what is that you are going to do? Okay. So first of all, you're going to have a specification document, right? So in that particular doc, you're going to have what are the set of inputs or outputs or what are about the protocol timing, what are the features of that particular design you're going to verify, and what are the type of mode operations, and what happens if you're going to have an error and how you're going to handle that particular error, performance limits, and how you're going to apply the reset and all. Those and all kind of things will be present inside your design specification document. As a verification engineer, studying that particular document is very, very important. Okay. Like, let's say, suppose if we are going to work on verifying a particular bridge, like UART to SPA bridge, you cannot simply go and try to verify that or write down a verification code. No, it's not that. You first of all need to have a good understanding of how UART works, how SPA works, how the design is converting UART to SPA, and what is the mechanism you're going to use, how you're going to latch, and there will be timing related things and all. You need to have a first of all good understanding about those particular things, and then you're going to start with the verifying. Okay. Now, uh, so as a verification engineer, you are going to test your design rigorously. Okay. In that particular different test cases, you are going to have some kind of normal scenarios or some kind of corner cases. What do you mean by corner cases is those particular bugs will not be visible or those particular bugs will be hidden. Okay. That are nothing but my corner cases or illegal cases or stress condition or random traffic randomly generating. Okay, so these are all the kind of different test cases you can think of implementing on your particular design. Okay, so why we need to verify our design? So why we need to verify our design, guys? What is the need of having the verification? Any answers? Why we need to verify our design? Let's say if you're going to have a mobile phone, right? um, if you have bought a mobile phone and if you're trying to turn on it by using the power button, but if you're pressing the power button, it's taking your pictures. Okay, so it's kind of a bug, right? You're trying to click the power button, but it is trying to take your picture. Then it's kind of a bug. It has not been tested, right? If it is not been tested, your design is not been tested, then it is kind of having a bugs. Okay, that's the reason before delivering any particular product or any particular design, you need to rigorously test it. Okay, because if the client is if we are delivering a project to our client and client is doing some kind of testing and if he's getting some kind of error, it's he's buying our product, right? So it's not his duty to take buy our product and what to say, debug whatever the bugs we are going to have it in our design. Okay, so that's the reason. Obviously there will be minor bugs when we are going to uh, design any product and we are going to deliver anything, but we need to make sure that at least 99.99% our particular design is bug free. Okay, that's the reason we are going to have a lot of test cases written while verifying our design. Okay, so here in the case of our decoder based RAM, since we are doing this particular project of decoder based RAM, let's say suppose if we are going to have 128 locations and we are going to have four blocks. Which particular block is to be selected is decided by our decoder and read, write, enable. And what a verification engineer should think of is he need to first of all think of having a basic test, and after that we are going to have we need to think in terms of decoder test. Like, let's say suppose if I'm going to give a particular address, whether my decoder is capable of selecting a particular block. If I'm going to give a particular address, whether my decoder is going to select a particular block or not. For example, if I'm going to have let's say four blocks, then if I'm going to give a particular address which is associated with this first block, then whether my decoder is going to select this particular block or not, is it able to select this or not. Let's say suppose if I'm going to give an invalid address to my decoder, then is it selecting a slave, or is it what kind of response it is going to give when I'm going to give an invalid address to my decoder. This kind of test you need to do in the case of my decoder test. And also we kind of having something known as boundary test. Like, what happens if we are going to give the address which is at the starting or at the ending. Okay, these are nothing but my boundary test. And also have some kind of test as stress test. That means I'm randomly writing, and I'm randomly trying to read what is going to happen, whether my design is able to capable of responding to that kind of stress test. Or else, let's say suppose if I'm going to give the illegal test, like suppose an invalid kind of addresses, if I'm going to give, what is my design responding to. This kind of test cases I'm going to develop, lot of test cases I'm going to develop in my system Verilog. So to make sure that my particular design is working on it exactly, to avoid malfunctions and to work accordingly to the requirement. Exactly. That's correct. Okay. That's the reason you're going to think of having multiple test cases in your verification document. Whenever you're going to verify a design, you are going to have something known as V plan. In that, you are going to have what kind of test cases you are going to have. According to the design specification, you are going to have different test cases. You're not actually writing the code initially. In the case of your vPlan, when you're going to decide what kind of test cases you're going to have, you're going to write them theoretically or write them manually, like in English, like you're going to write down what kind of features you want to test and all. So that whoever is going to develop the system Verilog code for them, they're going to refer to the vPlan. Okay, I need to have this test case written, so they are going to use constraints and all. Okay, that and all, how to develop different test cases and all, we are going to see. Okay, anyways. And there's one more kind of thing which is known as a regression. Okay, so regression testing in VLSI verification means we are going to rerun a particular collection of previously created test cases whenever RTL or test bench changes are made, to ensure that new changes does not break existing functionality. For example, let's say if we have a particular design, and in this particular design we have written few test cases: test case 1, test case 2, test case 3, test case 4. In test case 4 we have found out a particular bug which is present. Okay, now what we will do, we will make modifications to this particular design to make ensure that this particular bug has been removed. Now, instead of moving forward with test case 5, test case 6, and test case 7, we are going to make sure that whether if we have removed this particular bug, then again, if we are, let's say, suppose, let's consider a scenario. In test case 4, we have found a bug and we have removed it. And let's say, if we are again running test case 1, another new bug has been created. If we have removed that bug which was present in test case 4 and we have running the test case 1, the bug which was not present when we were running test case 1 previously, but now appeared when we have removed the previous bug. So this kind of scenarios may happen. So you might think like, if I was running test case 1, there was no bug. Test case 2, no bug. Test case 4, I have found a bug, I have removed, and moving with next test case. No, you need to come back and you need to check it again, that whether you have removed this bug and any other bug is going to appear in the test case 1, test case 2, or test case 3 previously. Okay, so you need to run this test cases again and again if you are removing any particular changes, or if you are going to make any changes in your design. This is nothing but your regression testing. Okay, so is it clear, guys? What I mean, is it clear? Yeah. Okay. So this is also we are going to see what do you mean by regression testing, and how we are going to perform it and all. Okay. Yeah, this is a example written over here. Suppose yesterday we are going to verify a particular RAM where all this particular test cases has been passed, like write retest, boundary test, reset test, and random traffic test. Now, let's say if the designer fixes one decoder bug, now we need to rerun all this particular test cases again, and we need to make sure that for all this particular test cases, if new bug is not being occurring. Okay, so this repeated validation is nothing but my regression testing. Okay. Yeah. Now, that is what I was saying about. So why we need this? Because the fixes may accidentally break read path or another block select or timing behavior. And this might give a particular, another particular bug. Okay. So that's the reason we are going to uh, run multiple test cases using our regression testing. Okay. Yeah. So this was about all the test cases and all which we are going to do. Now, let's say suppose if you're preparing for one particular exam, okay, like let's say suppose your particular examination is after a week. Now you are going to make sure that you have covered all the syllabus or not, like you have covered all the 5 chapters or not, or you have covered all the 10 chapters or not, right? So that is nothing but you are basically performing coverage, that's it. Whether before going to exam you have covered all the particular topics or not, or the all the particular chapters or not, that is nothing but it's kind of a coverage, right? Here also in the case of my system Verilog, I'm going to make sure that I have covered all the particular features or not. Okay, so if I'm going to have a particular decoder based RAM in our particular example, I have covered all the particular RAM addresses or not, or I have generated all the particular possible data, or I have generated all the particular address possibilities or not. I have covered all the particular test cases or not. I should have some kind of metric, right? Okay, that particular metric is nothing but my coverage. Okay, basically coverages are divided into two types. One is code coverage and another is functional coverage. Okay, so basically in the case of your code coverage, you're going to deal with the code which is present inside your design. For example, if I'm going to write down a particular design, and let's say if I've written some if block and else block, this is some design number one. And in another design, what I'm going to do is I'm just writing down if, but I'm missing else condition. Now, is my code going to compile? Yes, it is going to compile. There is no wrong in it. But in terms of your synthesis, this will affect. It will give you a latch condition, or it might give you some other kind of functionality if your else condition is missing. Here, what is being not covered, else is not being covered. So this kind of bug will be founded out in your code coverage. So code coverage can basically able to check whether all kind of branches are being covered or not. Or let's say suppose if you are going to have an FSM, like you have different states S1, S2, and S3. Okay. Like code coverage will make sure that you are being traveling from one state to another state or not, one FSM state to another FSM state or not. Like this code coverage have so many features, it can check it out whether a particular line is being executed or not, or whether if you are having a FSM, whether you are traveling from one state to another state or not, or whether you are having a branch, then you are writing all the possible combinations of that particular branch or not. So this is what code coverage is going to look. Okay, so code coverage, we are going to have block coverage, like how many, whether all the lines of that particular block are executed or not. And we are going to have expression coverage, FSM coverage, and toggle coverage. Anyways, we are going to discuss in detail about this code coverage later. Just I wanted to give you an overview of how code coverage is going to look like. Is it clear, guys? Any doubts or any queries in the code coverage? How and what are the extra features which are present in the code coverage? Anyways, we are going to look into in more great detail. Okay. Yeah. Now, apart from this code coverage, which we were having, it's kind of a metric. Okay. So code coverage, we are, as a user, we need to write it down. Okay. User is going to write it down in our particular QuestSM or whatever the tool which we are going to have. In the code itself, we are going to write it down. And other kind of metric is nothing but my functional coverage. Okay. So basically, code coverage was checking. Yes, yes, I'm coming to that particular point. So basically, code coverage was checking how much amount of code or up to what extent your code is Correct. Okay. And please remember one more thing. Like if you're going to get code coverage as 100 percentage, that does not mean that your code is functionally correct or your code is bug free. No. Okay. It is going to check whether all the particular, what to say, all the particular predefined set of coverages are satisfied or not. It's like basically a type of metric like thing. It is going to check whether all the particular conditions you have given is it satisfying or not. Okay. And coming to my functional coverage, code coverage was basically depending upon kind of checking whether all the lines of code is correct or not, or whether you are missing something or not. And coming to functional coverage, it is going to check whether your functionality is being covered or not, your functionality is being correctly tested or not, up to which extent it is being tested. Okay, that is nothing but your functional coverage it is going to deal with. So, functional coverage, it is going to deal with covering design functionality or feature metrics, whether you are basically checking all the features of all the functionalities or not. Okay, and this is also user defined metric that tells about how much design specification or functionality has been exercised, how much amount or up to which extent we are basically testing our particular design or not. And the functional coverage is basically can be classified into different categories. One is data intended and another is control intended, where in the case of my data, we are going to check whether occurrence of data value combinations. For example, if I'm going to have a 4-bit data, then I can have different combinations from 0 to 16. And for a particular design, this particular data, if I'm going to give, and let's say if I'm going to test by providing the data from 0 to 5, it is working fine, and I've given a stamp, it's working fine. But let's say if there is a bug whenever you're going to give the data from 16 to 15, then this is a bug, right? So you are not providing the data, possible data items from 6 to 15. You're only providing the data items from 0 to 5 in your test cases, and you're stamping your design is correct. But coming to the data which is 6 to 15, if you're going to provide, then you might get a bug, but you're not providing it in your test case. Functional coverage is going to catch that particular point. You're not basically testing your data, or you're not basically testing your design with this particular possible combinations. Functional coverage is able to find it out. Okay. So this we need to write it down. So in the functional coverage, we are going to use something known as bins, and we are going to use it. Okay. And as I've said you previously, it's a user defined metric. It is up to the verification engineer to consider all the features, because if some features are missed to add in the functional coverage and remaining features are covered, then functional coverage will obviously show 100 percentage. Like wantedly, let's say suppose if I'm not including this particular feature in my functional coverage, then functional coverage will show me 100 percentage that user has tested the design very well, and it is going to give me 100 percentage. But there is a bug, but that intentionally you haven't mentioned in your functional coverage. Obviously the tool is not going to find it out. Okay, so that's about your introduction to functional coverage and code coverage. Is it clear, guys? Any doubts or any queries in this? Shall we move forward? Is it clear? Anyone wants to ask anything? Okay, hope everything is clear. Now, so coming to my particular, why do we use a functional coverage? This is what I was explaining about. So in verification, running random test alone is not enough. Okay, so we might run 10,000 particular tests, but we might still miss a particular important case, like writing to the highest RAM, or simultaneous enable plus write, or invalid decoder select, or boundary transitions, or read after write same location. This functional coverage will help us to identify what is the missing scenario, or what is the missing test case, which we can able to find that particular bug. Okay, for that functional coverage will help us. Now, how to declare a particular functional coverage model is, the first step is we need to define a coverage model. For declaring a coverage model, we need to have a cover group. Okay, this is our keyword which I'm going to use. Now, so cover group is a user defined construct. It's a user defined construct, and we need to declare it in our code, which encapsulate coverage model specification. So cover group construct can be instantiated multiple times, various contexts using new operator. So we are going to declare a kind of coverage model using the keyword which is known as cover group and followed by instance name we are going to have, and here we are going to write some kind of code that we will discuss anyways. And for creating the memory of this particular cover group using this particular instance name, we are instance name is equal to new. So for this, a memory will be created and we are going to have the coverage for this particular whatever the thing which we are going to have. Now, what is coverage going to include? It is going to have some kind of coverage points and cross coverage and clocking event and coverage options and optional formal arguments. No need to worry about this. All these technical terms we are going to see in detail, like what is this and all. Okay. Yeah. So this is how we are going to declare a particular coverage group. We are going to have a keyword which is known as cover group and coverage model name and followed by end group. Here we are going to write down our code. Okay. And if we want to create the instance for this, we are going to have coverage model name and followed by instance name is equal to new. Then only the coverage will be done. Now, and also we can have the clocking event, like when this particular coverage should be done at positive edge or negative edge, or what particular clocking event you need to have this particular coverage to be done. Okay, you can have an event over here. Now, let's see about cover point. Now, let's say suppose if I have my design and this particular design is going to have write enable and read enable. These are the two inputs I'm going to have for my design. Now, this particular write enable and read enable, I need to make sure that it has given all the two values from my test case. That is, write enable is made to 0 or not, and write enable is made to 1 or not. In my test case, using my test bench or using my test cases, whether the user is providing write enable is equal to 0 and whether the user is providing write enable is equal to 1, or whether my user is providing read enable is equal to 0, or whether my user is providing read enable is equal to 1. Whether, let's say suppose if the user has defined a test case where he is providing only read enable to 0, but nowhere he is providing read enable is equal to 1. Then let's say read enable if he is providing, then read enable if he is providing as 1, then he might get a bug, but he's not providing it. Okay. This should be catched using your coverage. Okay. Now, this particular point we are focusing upon is read enable, and this particular point we are focusing upon write enable. The variables which we are focusing is read enable and write enable, and this particular variables as termed as cover points. Okay, at which particular variable you are focusing upon, that is a point. Okay, so a cover point is an integral expression or a variable that has to be covered on sampling of the cover group. Okay, so on which particular variables you need to have a look using your coverage model, or on which particular point you need to have a look into the functionality. Okay, so here in this particular example we can see, so we have declared a cover group and the event we have mentioned, and this is a label. Just a cp1 and cp2 are labels, these are optional, and you are mentioning something known as cover point. So cover point over here is a keyword which you are going to use. Then what happens, you are going to look into this address, whether this address is having all the particular possible values or not, and you're going to look into this particular data, whether this particular data is going to have all the possible values or not. The coverage model is going to check it and it is going to give us the result. Okay, now let us try to understand how it is checking and how it is giving the results, on what basis it is giving. Okay, so it is basically using something known as bins. Okay, so we have two type of bins which are there. One is implicit bins and another is explicit bins. Now, implicit bins are kind of bins which are being created by the tool itself. You don't need to create. You just write down cover point address, cover point data. Bins will be created automatically for this particular address and data. Now, what do you mean by bin and how coverage model is basically giving us the coverage report and all? Let us try to understand. Let's say if I'm going to have a particular cover point as address. Basically, I'm focusing upon this address. Now, this address is declared as 2 down to 0 address. Now, what happens over here is tool will create how many bins? Tool will create 2 power n bins where n is the variable width. So tool will create over here 2 power n where n is the number of bits. So basically tool will create 8 number of bins for me. Bins. Okay. Now let's assume this is bin 0, bin 1, bin 2, so on. It is going to create total 8 number of bins. And let's say if the test case developer or the test bench developer has written a test case where address value is given as 0, then this bin is said to be as hit. And let's say if the test case developer has developed a test case where address is being given as 1, then this bin is said to be as hit. Okay, that's it. Uh, the test case developer is only developing a few test cases where in that particular test cases only address is equal to 0 and address is equal to 1 has been generated and only 2 bins are being hit. Now, the percentage of coverage, basically the percentage of coverage is mentioned as number of bins hit divided by total number of bins. Total number of bins. So the total number of bins we are going to have over here is 8 and number of bins hit is 2. So 2, 1 is nothing but 1 by 4, which is nothing but 0.25, and if we convert it into percentage, it is 25 percentage. So you're going to have 25 percentage coverage. So yeah, so you're going to have 25 percentage coverage. Now, whenever you're going to have look into the coverage report, there will be something known as coverage report. In that coverage report, you're going to look into this cover points. In this cover point, you're going to see the bins which are hitting for this address and the bins which are missing for this address. You will come to know that okay, only the bin which is corresponding to 0 is been hitting, only the bin which is corresponding to 1 has been hitting. Other bins, the address 2 and 3, 4, 5, 6, 7 are being missing. So you're going to develop another test case such that these bins are being hitted. Okay. So that's how you're going to write down multiple test cases depending upon the coverage report you're going to have. And you are going to make sure that this particular coverage report will be increasing from 25% to 100%. Not only for this particular address. Whatever the variable you are going to have, you are going to write down a particular cover point and you are going to make sure that all the bins are being hit. If it is hitting that, you are going to make sure that, then you are going to make sure that okay, that particular address or that particular scenario has been generated by my test case and I have come successfully verified it. Okay, so this is how you're going to use your functional coverage for pointing out or for finding out what exactly the bug and where exactly the bug is using the concept of cover point and bin. Now, there will be something known as explicit bins that we are going to start our discussion tomorrow. And we are going to have something known as cross coverage that also we are going to start tomorrow. And how to run this coverage and how to check the coverage reports and also we are going to look into in our next session. Okay. Yes. So any doubts or any queries till now?